Hi everyone and welcome back to my channel cloudtext.club. I'm excited to kick off a brand new series focused on Git and GitHub, a quick and practical journey through one of the most essential tools in the DevOps toolkit. Now, just to clarify, this doesn't mean I'm wrapping up the existing Kubernetes and Ansible series. Those are very much active and new videos for them are already in the pipeline. I'll be updating those series soon. This new series on Git and GitHub is designed to take you from the basics all the way to advanced concepts with a hands-on approach that fits right into the larger DevOps learning path. So let's jump right in with today's topic, an introduction to Git, a powerful and widely used source code management tool. So in this lecture, we will cover the fundamentals of source code management, SCM. We will explore how it works using the Centralized Version Control System, CVCS, and Distributed Version Control System. We will also dive into some interesting facts about Git, one of the most popular tools in this space. But first, let's understand why we need Git in the first place. Before jumping into how it works, it's important to know the problem Git solves, like code versioning, collaboration, and tracking changes effectively in any development workflow. In IT companies, software development is typically a collaborative effort involving multiple developers. Each developer works on different parts of the application, contributing code in smaller segments. Managing and integrating these code contributions effectively is what we refer to as a source code management. For example, let's take a large scale platform like Facebook. Some engineers might be working on the login page, while others are focused on different areas like the newsfeed, messaging, or notifications. Each team handles a specific part of the application. In the past, before modern tools like Git existed, all these code contributions were often merged manually, which was not only time consuming but also highly error prone. There were no reliable way to track changes, manage versions, or collaborate efficiently. To overcome these challenges, various tools were developed to handle source code management and maintain proper software versioning. These tools help track changes, collaborate efficiently, manage different versions of the code base, and ensure smooth integration across teams. There are two main approaches to source code management. One is centralized version control system. Another one is the distributed version control system. So let's proceed with understanding what is centralized version control system and how it works. A centralized version control system, CVCS, relies on a single repository to store all the code and version history. In this system, every developer checks out the latest version of the code from the central repository, makes changes, and then commits those changes back to the repository. Let's take an example to understand how the centralized version control system works. Suppose this is our central repository server. We have workstation PC1, PC2, PC3. Suppose PC1 works in the IST time zone, or we can say this developer is sitting in the IST time zone, while this developer is working in the US time zone. Now, the IST time zone developer logs in and made few changes into the code and pushed the changes to the central repository. The same code will be checked out via US time engineer once he will log in. Then he will make few changes into the code again, let's say with some green lines, and pushed the code to the central repository, and the same code will be used by IST time zone engineer once he will logs back in. In this way, the project is synchronized across time zones with engineers working on the same code base but at different times, commenting and pushing their changes to the central repository. This allows the team to collaborate across regions while ensuring everyone works with the latest version of the code. Let's see the advantages and disadvantages of the CVCS. First is the simplicity. Another one is the centralized control. It is easier to set up and use, especially for smaller teams or projects, while it provides the centralized control. A single repository for all changes means a centralized management of the project. Likewise, we discussed here in this example. And disadvantages. First, it's going to be the single point of failure. Next, limited offline capabilities. So, if the server or a repository went down by any chance, PC1 won't be able to update the codes to the central repository, and PC2 will not receive the updates. So it's having the single point of failure. No one can access or update the code. Next is the limited offline capabilities. So developers must be connected to the central server to commit or update the codes. Otherwise, it's a single point of failure. Let's proceed with understanding the distributed version control system, where each contributor has a local copy or clone of the central repository. This means every user maintains their own complete local repository, which includes all the files and metadata from the main repository. Let's understand this with the help of a diagram. Let's say this is your central repository. You have PC1 or workstation 1, PC2 or workstation 2, PC3 or workstation 3. This is we are discussing DVCS. One of the examples of DVCS is Git. Okay. Here we have local repository. This is going to be the again local repository. This is also going to be the local repository. This is our workspace. where we write the code. So from workspace, we commit the code to the local repository, and from local repository to the central repository, we push the code. And we pull the code from the central repository and update from the local repository to workspace. Same here. This is going to be the pull request. And this is going to be the update, pull request and update. Let me write it here as well. This is going to be the push request and commit, push and commit. So this is going to be your local machine. So you have local repository sitting on your local machine and your workspace. While this particular repository, the central repository, it can be your GitHub, while Git works at this level. Okay. So let me read the DVCS. Each contributor, each PC, each workstation is having the local copy here, local copy or clone from the central repository. This means every user maintains their own complete local repository, which includes all the files, metadata from the main repository. So this is how the DVCS function. As I told, central repository can be GitHub, and while the Git tool works on the local PC. So in short, Git is the tool, while GitHub is the platform that helps, shares and manages Git repositories, right? Let's go ahead and see few advantages of using the DVCS. There are a lot of advantages, but I will discuss few of them which are very important. First one is local repository access. Each developer has the full copy of the repository, including the history, allowing them to work offline without needing a constant connection to the central server. So they can work within the offline state of central repository. Another one is the faster operations. So most of the operations are performed locally, making them significantly faster compared to the centralized system. Enhanced data safety. Since every contributor has a full copy of the repository, locally, right? It's more resilient to data loss. Even if the central server fails, any clone can be used to restore it. Full history tracking. Every clone has the complete history, enabling better traceability and auditability of changes. Another one is the reduced dependency on central server. Unlike CVCS, which is our central versioning control system, distributed versioning control system does not rely heavily on the central server. It reduces the single point of failure. So as we saw earlier, single point of failure was the disadvantage of the CVCS, which got resolved with the help of a DVCS. Okay, let's discuss the different stages of the Git and its few of the terminologies. There are 3 stages of Git. One is workplace, another one is the staging area, the third one is the local repository. So workspace is the place where you work on your files, modify it and write the codes. Another one is the staging area where you prepare the changes before committing, and the local repository where Git stores the history of your commits. Let's understand this with the help of a very simple example. Your workspace is like your room where you have all your clothes. This represents the files you are actively working on in your project. The staging area is like a suitcase where you pack the clothes you plan to take on a trip. These are the files you have selected to commit. The local repository is like your travel destination. Once the files are committed, they are safely stored there and you can access or revisit them anytime. Let's understand this with the help of a small diagram to make it more clear. Git stages. So there are 3 stages. What we have: workspace, which we also call as working directory, where we write the code and modify it. Staging area and local repository. So let's say you have one server. Okay, it's just for an explanation purpose. There are 3 partitions. Okay, this is your workspace This is your staging area, and this is your local repository. Let me have different color. So this is your workspace. This is your staging area, and this is your local repository. And here you have a central repository, which is GitHub. Okay, so the workspace, this is where you create, edit and delete files, essentially your active deployment area. All visible files on your local system reside here on the workspace. Next is your staging area. Before committing changes, you first add them to the staging area. Think of this as preparation zone, where you group specific changes that you plan to commit. Next is your local repository. Once changes are finalized in the staging area, they are committed to the local repository. This stage saves the snapshot of your project along with metadata, forming part of the project versioning history. From workspace, the file can be sent to the staging area with the help of add command, and from staging area to the local repository using the commit, and from local repository to the central repository using the push, and from central repository it can be pulled to the local repository using the pull. So these are the three stages of Git. There are various terminologies which Git uses. We will discuss all of them one by one. So the first is your repository. Okay, a repository is a storage location for your project source code, where you keep the code, project code, right? These are of two types: local repository, and the another one is the central repository. This is like GitHub, or you can say it's a Git tool which works on the local repository. Next is the server. So server is the platform where you host all the things, right? Remote repositories and manage associated metadata such as commit IDs, tags. It enables collaboration by allowing multiple users to access and contribute to the same code. Another one is the working directory, which we have already discussed, a workspace, right? Another terminology is the commit. A commit records changes made to the files in the repository. Each commit generates a unique 40 character alphanumeric identifier known as commit ID. So whenever you make changes to any file within the repository, it generates a 40 character alphanumeric identifier, which is a commit ID, to identify that this particular change was done by this particular user. That's how it keeps the track of the changes of the versioning within the system. So we have commit and the commit ID. Another one is the snapshot. A snapshot captures the state of the project at the specific point in time. Git uses the incremental model. It uses the incremental snapshots, meaning it stores only the differences since the last snapshot rather than the full copy of the project each time. And the another one is the push. The push operation transfers the committed changes from the local repository to the remote repository, while the pull operation, the pull operation retrieves the changes from the remote repository like a GitHub to the local repository. So these were some terminologies which we use with the help of a Git, which we discussed, like repository, server, working directory, commit ID, snapshots, push, pull. Let's see few advantages of Git. First one is it's free and open source. Git is freely available and open source, making it accessible to individuals and organizations without licensing cost. Another one is the fast and lightweight. Git performs most operations locally, such as commenting, branching, and viewing history. This local execution results in high speed and minimal latency. Next one is the security. Git ensures data integrity by using a cryptographic hashing algorithm, SHA-1, to uniquely identify every object, such as commits and files in the repository. This prevents tampering and ensures consistent tracking of changes. No need for high-end hardware, since Git operations are efficient and primarily local. It does not require powerful hardware as always on internet connectivity. Next is efficiency. Branching. Creating a new branch in Git is quick and efficient. Git uses lightweight pointers, so branches are created without duplicating the entire code base, enabling seamless experimentation and parallel development. So branching is altogether a big topic within Git. We are going to cover this in our upcoming lectures. Hi everyone, and welcome back to my channel CloudTech's Club. In our last lecture, we covered the fundamentals of source code management. We explored how source code management works through centralized version control systems and distributed version control systems. Additionally, we deep dived into some interesting facts about Git, one of the most widely used tools in this domain. Let's jump into the quick demo between Git and GitHub in action, where we'll walk you through the steps and show how Git works locally and how it integrates with the GitHub. So this demo will help you understand how local development connects with remote collaboration. So here are the steps we will be performing in the lab session, which I have already outlined in the presentation. I will share a link to either my blog post or GitHub repository in the description later for your reference. With that, let's jump into the lab. Okay, let's proceed with the installation of Git onto the machine. For this, I'm going to write yum install git -y. There's a way to install it on the Windows as well. We will see that in our upcoming lectures. Now to check the version of the Git, let's run the command git --version. So we can see the version we are running here is 1.8.3.1. Now let's configure the user details. I'm going to run the command git config --global user dot name cloudtix. I'm going to configure the email. User dot email is going to be the cloudtix dot club@gmail.com. Now create a directory or use existing one and go inside it and initiate Git. For this demo, I'll be using almost the same directory in the files we created during our Ansible lecture. This will help us build on what we have already done, making the process smoother and more reliable, So let's go ahead. cd test scripts. So right now we don't see the Git is initialized here. We are going to initialize the Git. So it says initialized empty Git repository in /root /test script /git. Let's see if it's initialized. Okay, you can see the .git here, right? Okay, let's see what are the untracked files here. We can see with the help of an command git status. So you can see the untracked files. We have 3 untracked files: dictionary.yaml, multiline.yaml, single-line.yaml. Now let me explain this with the help of a diagram as well. In our last lecture, we talked about Git stages, right? We have 3 Git stages. One is workspace, which we call it as a working directory. Another one is the staging area, and the third one is the local repository. Let me make a quick diagram here. We have 3 partitions. So this is our workspace. This is our staging area, and this is our local repository. Now I have 3 files. Let me write it here. Single .yaml, multi .yaml, and dictionary .yaml. Now these files are sitting within workspace right now, and these are untracked files. I hope you got my point, right? Now we are going to move these untracked files into the staging area by using the command git add. And from staging area, we are going to move them to the local repository using the command called git commit. So let's go back to the lab and execute this. Let's move the files from working directory to staging area. We can write the command git add dot. So dot here represents whatever the files are there within this particular directory, test scripts. It will move all of them from working directory to the staging directory. Now let's check again the git status. So now you can see there's a difference in both the outputs. These are the untracked files, and now here it changes to be committed. Now let's commit the files to local repository. For that we are going to run the command git commit. We are going to write -m. This is for the message. I'm going to write the message as Ansible scripts. Okay, now it says master root commit. Let's check the git status. Nothing to commit, working directory is clean. So now the files are moved to local repository. Now let's check the git log to see the commit ID. So this is the commit ID which we talked about in our last lecture, and this is the message what I gave, and the author which I configured, and the email which I configured previously, and the date and the time. So this is how the tracking is being done with the help of a git. Let me show you more information of this commit ID. So here we can see what has been committed with the help of these files. There was a code. Okay, now let's push the codes to central repository, which is GitHub in this case. I'm going to open my GitHub account and going to create one new repository there. Let's create a new repository. I'm going to name it as a test 007. It is available. I'm going to just mark it, leave it as it is. Rest of the things, going to just create the repository here. Okay, so the repository is being created. I'm going to take this output and going to write the command git remote add origin and the link. Okay, now I'm going to push the files, git push -u origin master. I'm going to commit this or going to push this within my master. It is going to ask my cloud text club 007. That's going to be my username and the password. For password, I'm going to create a quick token key. Let's go to the account and let's go into the settings. Let's come down on the page. Let's go to the developer settings and tokens. I'm going to generate a new token. Going to name it as test 007, the same as it is what we did. I'm going to select all of them. And hit generate token. So here's the token ID which got generated. I'm going to give it here. Okay, so the files got pushed to my GitHub account. Let's go ahead and verify. Let's go to the repositories, test 007. And here I can see all the three files, the dictionary.yaml, multi-line YAML and the single line YAML. Let's deep dive into the concept of Git branching. First, let's understand why branching is required in version control. So branching in a production environment ensures that the stable production ready code is kept separate from ongoing development work, which reduces the risk of errors or disruptions. For example, a feature can be deployed in a separate branch while the production code remains intact. This allows for parallel development, quick bug fixes through hotfix patches, and safe deployments without affecting the live system. So once features are ready and tested, they can be merged into the master branch for deployment. Let's understand this with a practical example and a diagram. Imagine we have a website like facebook.com where multiple developers, developer 1, developer 2, developer 3 are working in various features. So one of the developer is tasked with building a new feature but has a different approach in mind than the existing design. Let's say this is that developer. To prevent any disruption to live and production code, we won't allow the developer to make changes directly into the master branch. So this is the master branch. Instead, we create a new branch, let's say a branch 1, and provide them with the complete code in this isolated environment. This way, a developer D1 can plan, code, and test the new feature without affecting the production, which is running in the master branch. So once the feature is developed, the developer can present the final result, let's say suppose here, and if it is approved, it can be merged into the production. If not, we can discard the changes. With this, we can say by using branches for each developer, it becomes possible to work on both simultaneously while keeping the main master branch free from errors. It is recommended to create a separate branch for each task. After completing the work on a branch, merge it back with the master branch. This approach facilitates parallel development. Let's go ahead and understand this with another diagram. Git operates with 3 stages. Git stages. We discussed this earlier in our lecture. First stage is workspace, which is also known as working directory. Another stage was staging area, and the last stage was local repository. Okay, now let's say this is our server where we created our directory called test scripts. When we initialize Git in a directory called test scripts, we use the command what? Git init to initialize the directory. It automatically creates branch by default. It is known as master branch. It is not recommended to work directly with the master branch for making any changes. For example, if you have few developers working within the team environment, suppose you have a developer 1, developer 2, developer 3, where you have assigned individual branches named branch 1, branch 2, branch 3 to the developers. You can create separate branches for each developer to work on. If there is code already present in the master branch, it will be copied to the branches during the first time when it will be created. If the master branch is empty, the rest of the branches will also be empty during the first creation. Any code written in branch 1, suppose this branch 1 will remain specific to this particular branch and will not be visible in the master branch. It will not be visible in the branch 2. It will not be visible in the branch 3. This isolation allows each branch to evolve independently without affecting the others. Let's see few key points to remember while creating the branches. Let me write it here. Key points which we have to remember. Number 1, you can create as much as branches as needed. So there is no limitation on creation of the branches. You can create a lot of branches within this particular environment, with changes being specific to each individual branch. So as we talked earlier, any change you will do within this branch 1, it will be specific to this particular branch. The default branch is the master branch within the local repository. When new branch is created, it copies the data from the existing branch during the first time. And the last one is files created within a workspace are visible across any branch workspace until those are committed to the local repository. Once committed to the local repository, the file is associated with that specific branch. This particular point we will see during our lab as well. Just for now, remember, whenever any file you will create within the workspace, it will be visible in all the branches and the master. Once committed to the local repository, it will be specific to that particular branch. Let us understand few commands for creating the branches. To check commit history, we can use the command the git log --1 line. To see available branches and which is the active branch among the branches which are there in the repository, we can use the command the git branch. The asterisk symbol indicates the current active branch into the directory. In this particular example, you can see the asterisk in front of the master. So the master is the active branch here. In order to create a new branch, we can use the command the git branch and the branch name. Now, to switch to a different branch, we can use the command the git checkout and the branch name. And in order to delete a particular branch, we can just use the command the git branch -d and the branch name. Let's jump into the lab to see the practical demonstration of Git branching. Let's switch to the repository test scripts which we created in our last lecture. CD test scripts. Let's check the contents of the test scripts workspace directory with the help of ls-la. So you can see the Git has already been initialized here, and I already have 3 files, the dictionary.yaml, multiline.yaml and single-line.yaml. Now to check what commits has been done so far in this particular repository, we can use the command git log --1 line. So I can see one commit is already present within this particular branch. Now to see in which branch I'm working right now or which particular branches are present within this particular repository, we can run the command the git branch. So I can see there is only one branch which is master, which is a default branch. And how we can say this is the active branch? There is an asterisk in front of the master branch. Let's see the contents of this file of our master branch ls-la. So these are the contents right now. Now I'm going to create a new branch for this particular repository. Let me clear this. Git branch cloudtext-sample. So I have named this branch as cloudtext-sample. Let's verify it got successfully created or not. So I can see now I have 2 branches. One is by default branch which is master, and another branch which is cloudtext-sample. But right now we are working in master. Okay. Now let's check out to the cloudtext-sample and verify the files which are present within master are copied to newly created branch for the first time or not. Okay. So git checkout cloudtext-sample. Now you can see the message here, switched to branch cloudtext-sample. Let's see the content by giving the command ls-la of this newly created branch. So all the contents are same. Now let's verify in which branch I'm working right now. Git branch So I can see asterisk in front of my cloud text hyphen sample. So this is the active branch right now. Let's see what commits has been done in this particular branch. Log hyphen 1 line. So we can see the same commit which was done in the master, the same is being copied to the cloud text hyphen sample. So I hope it is clear now. When a new branch is created, it copies the data from existing branch. Okay, now let's create a file in cloud text sample branch with a name called sample file. So let me verify if I am in which branch. So right now I am in cloud text hyphen sample branch. I'm going to create a file here, vi sample file 01. I'm going to write a very simple content in this. Hi, welcome to cloudtext.club. Now let's give ls-la, and I can see the sample file 01 got created within my branch cloud text hyphen sample. Now I'm going to add and commit this to the local repository git add dot and git commit hyphen m for message cloud text sample first commit. Okay, so commit is successful. Now I'm going to see the git log hyphen 1 line. Now I can see there are two commits within git branch cloud text hyphen sample. Now a quick question. Let's see if we will be able to see this file, the sample file 01 within master branch or not. I would like from someone from the subscriber end to provide the detailed answer within the comment box. It would be great to see if you are learning. Okay, meanwhile let's go ahead and check within the master branch. So git check out master. So we are switched to branch master. We can verify with the help of a git branch as well. So asterisk in front of the master branch. We can give the command git log hyphen 1 line to verify the commits. So here I can see only one commit, but within my cloud text hyphen sample branch I have two commits. So you can see the difference here, right? Okay, now let's see one more concept here. Let me clear this. I will just go ahead and git checkout to my cloud text hyphen sample branch. I am going to create a one sample file 02 this time. I'm going to write the content. Hey, How are you? All good? Just so the file sample file 02 got created. Let me do ls-la. So we can see 5 files now: dictionary.yaml, multiline.yaml, sample file 01, sample file 02, and the single line.yaml. This time I'm not going to add this file, the 02, to the staging area, and not going to commit it to the local repository. We are just going to switch the branch to the master. Git checkout to master. So you can see we have switched to master branch. Now let me do ls-la here. You will be able to see the sample file 02, right? Remember the key point which we discussed earlier? The files created within the workspace are visible across any branch until they are committed. Once committed, the file is associated with that particular specific branch. So this time we have not add the file to staging area and commit it to the local repository. Now let's move forward and deep dive into few more important Git concepts. Today we will start with Git merge. As the name suggests, Git merge is all about combining things, and yes, in this case we are talking about merging branches. Git merge is a command that lets you bring together changes from one branch into another. Think of it like combining two versions of a document. For example, if you are working on a new feature or bug fix in a separate branch, you can use Git merge to add those updates back into the main project. It helps keep everyone work organized and all in one place. Let's understand this with a simple diagram. Git merge. Let's say we have a server or EC2 instance or virtual machine. Where we have a directory called test scripts. Once this directory gets initialized with Git by using the command git init, it will be partitioned into 3 spaces. So the first one is workspace, second one will be the staging area, and the third one will be our local repository. So once this directory test scripts get initialized with the git init, it creates a by default branch called master. Let's create the master branch here. Where we already have the ABC code. Now developer comes in and wants to fix some bug for this particular code. For this purpose, we have created a new branch. Let's create a new branch. I will name this branch as branch 1. So once this particular new branch 1 will get created, this code ABC will be copied to branch 1 initially. Now developer works on the branch 1 and write some new code to fix the bug. Let's say XYZ code he has written here. Once everything is completed, the changes needs to be merged back into the master branch. During the merge, Git pulls the updates from the branch 1 into the master branch. After a successful merge, the temporary branch 1 can be deleted using the command. We discussed this in our last lecture as well. Git branch -d and the branch name. And the branch name here is the branch 1 in this particular case. Finally, the updated master branch can be pushed to the central repository. Let me make a central repository here. So the central repository in this case is our GitHub. There are few key points to remember while performing the git merge operations. You cannot merge branches from different repositories. Merging can only happen between branches within the same repository. And another one is the pulling mechanism is used to merge changes between the branches. Let's go ahead and understand them in a detailed manner. Suppose you have a server, let's say a server or a EC2 instance or a VM here, where you have two directories, directory 1 and let's say our directory 2. So once these directories get initialized via git init, they will have their own workspace, staging area and local repository. Same here as well. Workspace, staging area and local repository, which is having by default a master branch. Now suppose we have created a new branch here, the branch 1, branch 1. Let me just mark them. So this is my master, this is my branch 1, this is my master, and this is my branch 1. So let's read our first point here. You cannot merge branches from different repository. So this is my one repository, this is my one repository. It means I can't merge the branch 1. Let me make a different pen here. So I can't merge branch 1 with the master of directory 1. It is not possible. So merging can only happen between the same repository. So this is the one of the repository, directory one. So the branch one only can be merged with the master of directory 1, not with of directory 2. I hope this is clear now. Now let's see the another point. Pooling mechanism is used to merge branches within same repository. So suppose master is already having a code ABC. Once we create a new branch, ABC code will be copied to branch 1. Now developer writes some code, let's say XYZ. So during the merge process, only XYZ will be copied to master branch. So it will be copied, just a copy paste onto the master branch. So it is taking a pull request from the branch 1. And how we need to perform this operation? Suppose we are sitting in branch 1. We have to run the command the git status. So we have to check out from git branch. Sorry, we have to write the command git checkout from branch 1, and then we have to write the command git merge branch 1. Make sure when you run this particular command, you are sitting in master. Let's jump into the quick lab session. So I'm using the same machine which we used in our last lecture. Let's go into the test scripts. Let me write the command git branch to see the active branch. So I can see the master is active. We can see asterisk in front of it, and we have in total 2 branches, cloud text sample and master. Now let's see the contents of master branch. We have the contents. Let's see how many commits are there in this particular branch. One line. So I can see 1 commit is being done. Let's check out to the cloud text sample. Let's see the contents of this particular branch. Let's see how many commits has been done on this. I can see 2 commits are done with this particular branch. Let's check out from here to the master. Okay, now let's go ahead and merge it with the master. So I will use the command git merge cloud text sample. So I can see updating, fast forward and create mode sample file. Now let me run the command git branch. So I am in master branch right now and it is active. Let me see the contents of this particular branch. I can see the contents, and let me see how many commits has been done on this. So I can see 2 commits. Previously it was only 1 commit in the master branch. Now it shows 2. Let's discuss about the concept called git conflict. In general, conflict occurs when you try to merge the branches. Sometimes 2 branches may have changes in the same file, but in different ways. When you try to merge them, Git doesn't know which version to keep. This is called a conflict. When a conflict happens, you will need to manually review the file, decide what the file content should be, then save the changes, add the file and commit. to the local repository and complete the merge. If data is completely different, then it leads to a conflict. When do conflict happen? Let's see few situations here. Two people added the same line in the same file. One person edits a file that another person deletes, or changes in different branches overlap in way Git can't resolve automatically. Now, in order to resolve the conflict, open the file within the master branch. You will see both the contents. Note, it is not merged yet. You need to fix the content according to the requirement. Once done, it's resolved. Now Git understands this is how it needs to be performed, as you have verified the file yourself in that condition. After editing the file, no need to merge it again. Simply add the file in the staging area and comment. Let's have a quick lab session for Git merge conflict. I'm going to set up a repository here. mkdir git merge conflict. Let's move inside this particular directory and initialize Git. Let's create a file named merge.txt. Let's write content in the merge.txt here. Echo initial content. Control D to come out of it. Now let's add it into the staging area and commit to the local repository. Okay. Let's create and switch to a new branch. Git checkout -b. I will call this branch as feature branch. It will directly take me inside the feature branch, and it will also create the branch called feature branch. So you can see switched to a new branch, feature branch. Let's open the merge.txt. Let's write some content. Changes in feature branch. Control D to come out of it. Now let's add it to the staging area and commit over to the local repository. Okay. Let's switch back to the master branch. So we are in the master branch right now. We can verify with the help of a git branch file, git branch command. Let's write some content into the merge.txt here. Changes in master branch. Control D to come out of it. git add to add it to the staging area, and git commit to move it to the local repository. Okay. Now let's try to merge the feature branch into the master branch. Git merge feature branch. Now we can see a conflict. Auto merging merge.txt conflict, merge conflict in merge.txt, automatic merge failed, fix conflict, and then commit the results. Git status. The output is showing merge.txt is having conflicts. You have unmerged paths. Fix conflicts and run git commit. Now to resolve the conflict, let's open the merge.txt. We will edit this file. Let me show you the contents after modifying the file merge.txt. Now add the file to staging area. Okay. Now let's commit to the local repository. Branch. Check the commit history to ensure the merge was successful. Git log -- one line. So we can see resolved merge conflict between master and feature branch. Now let's proceed with understanding the concept of Git stashing. So git stash is a Git command that temporarily parks your changes you have made to your working directory so you can work on something else, then come back and reapply them later. Let's understand this with the help of a small diagram. Imagine you are working on a server, EC2 instance, or a virtual machine where you are having a test directory where you will initialize the Git and by using the command git init. Once the Git is initialized, it will be converted into a Git repository and having 3 spaces: workspace, staging area, and local repository. Now suppose you are implementing a new feature within the workspace and having a file abc.txt where you are writing some code. Your code is in progress within the workspace and suddenly a customer escalation comes in. Because of this, now you have to keep aside your new feature work for few hours. In this condition, you cannot commit or add this particular code into the staging area and the local repository. So you need some sort of a temporary storage where you can store your partial changes and later commit into it. In this situation, Git provides a solution called Git Stash. It's just like a temporary storage where we will park our partial code for some time. Now I will start working on writing the new code within the file, within the workspace. Once the work is done, I will push it into the staging area and within the local repository. Now I will start back again to implement my partial code. I will bring back my partial code from the Git stash into the workspace. Will work on it to complete the code. Once the code is completed, I will start adding it into the staging area and from staging area to the local repository by commenting it. I hope this is clear now. Let's jump into the quick lab session for the stash. I'm going to create a folder test stash. I will go inside the test stash and initialize Git. So Git is initialized here. I'm going to create a dummy file using the touch command, test file 01. Let's move this empty file to the staging area and commit to local repository. -m code file 01. Okay, we have committed this to the local repository. Let's see the active branch. It is master right now. Now let's write a quick code within the test file 01. Then bash. I'm going to check the list. I'm going to create an mkdir abc directory. Just give it Ctrl D to come out of it. Now suppose the developer got some urgent work and he need to work on the new task. In that case, Git provides a solution to move this partial code into the temporary place called Git stash. Now let's use the command git stash to move it into the stash temporary storage. So you can see it's moved here. Okay, now let me see the contents of this file. Now if you will open this particular file, it will be shown empty as data moved to stash, meaning our working directory is empty at this point. Let's run git stash list. You should be able to see one entry for stash. Yeah, so here is the entry. Now the test file 01 is empty. Let's write some code. The new task for the developer. Ctrl D to come out of it. Now we have written the new code within the test file 01. Now let's move this file into the stash as well. Let's use the command git stash. So this file also we have moved into the stash. Let's see the git stash list. We can see 2 entries there. Super, we have 2 entries. Now let's see the content of test file 01. Nothing is there. So far we have written 2 codes and moved them to stash. Now I want to work on my previous task or work which I moved earlier to the stash. Okay, so here is the catch. From entries stash at the rate 0, this is my recent task, and stash at the rate 1, this is my old task. Now I am going to bring my partial code which is there in stash at the rate 1. Okay, let's do it. Git stash apply. I'm just going to copy it. Stash at the rate 1. Give it enter. Okay. Now let's see the cat test file contents. Now you can see our old partial code is back into the working directory. Now let's move it to the staging area and then commit over to the local repository. Okay. Now let's apply the same procedure on our second code. I'm going to use the same command. Git stash apply stash at the rate. It's going to be 0. Okay. Now looks like it's leading to conflict. Why there is a conflict? If you will read this message, because both file names are same and one is already committed, we need to go ahead and manually modify the file and resolve this conflict. Let's go inside the file. Let me first show you the contents of this test file so you can see. Right, both are having a conflicts right now, so we are going to resolve this conflict. I'm just going to modify the changes. Now let me show you the contents of test file after the modification of file, after resolving the conflict. Now let's add it back. Git commit -m final code. Okay, now it's been committed successfully. Let's do one thing. Let's check the git stash list. Now work is still present within the stash list, right? So let's clear the stash by using the command git stash clear. Now let's run the command git stash list again. So the stash list is empty again. Alright, let's move over to the next section. Let's discuss about the concept called git reset. Git reset is a powerful command that is used to undo local changes to the state of the Git repository. In order to reset the files which are present within the staging area, we can use the command the git reset and the file name. Or to delete whatever the files present within the staging area, we can also use the command the git reset with the space dot. Now if you want to reset the changes from both staging area and the working directory at the same time, we can use the command the git reset --hard. Let's understand this with a small diagram. git reset. Let's say we have a server, EC2 instance or a virtual machine. Where we have a directory. Let me make it with a different pen. Now once this test directory gets initialized with git init, it will be partitioned into 3 spaces. Let me name it here. This is workspace. This is staging area. This is local repo Z-tree. Now suppose a developer has created a code file here. Let's say abc.txt, where he has written some code. Let's say a developer 1 here. He has written some code within the workspace directory and moved to staging area by adding this file. abc.txt, and realized there is some mistake within this particular file, abc.txt. In that case, if developer wants to reset this file abc.txt within the staging area, only within the staging area, he can use the command git reset file name, in this case abc.txt. This is the file name, right, in this case. Or if he or she is having multiple files moved to the staging area, in that case command can be used as git reset with a space dot. Now in order to reset the changes from both staging area and working directory at the same time, let me just mark it here. Now we want to make the changes from both workspace and staging area. We can use the command git reset --hard. Now let's quickly jump into the lab and see this in action, where the things will be more clear. I will go ahead and create a directory called test reset. Let's go inside the directory test reset. Let's initialize the git here by using the command git init. It's initialized. Yes, it's initialized. Now I'm going to create a file here by using the cat command test01. Let me write some content here. Hi, welcome to Cloud Text Club. Going to save it with the Control D. Let's check the git status. So the file is untracked right now. It means it is present in our working directory. Now I'll move it to the staging area. by using the command git add, and let's see the git status now. Now it is in the staging area. So I'm going to use the command git reset space dot to undo the changes. Now let's see the git status. Now the file is again, you can see, within the workspace only. It is not within the staging area. You can see the difference of output here. This is the staging area output and this is the workspace output. Now let's do one thing. Let me add this into the staging area again. Let's see the status. Now it's moved to the staging area. Now I am going to remove this from both the workspace as well as from the staging area. Let me write the command, the git reset -hard. Let's check the status, the git status. Nothing is there. It's cleaned everything here. Now let's move forward and deep dive into few more important Git concepts like Git Revert, tagging, along with Git repository cloning to the local machine. So let's first understand what is Git Revert and why we need this. So suppose a developer made a commit in Git repository, but later on realized the code was having a mistake. That's where we have a solution of Git Revert. The Git Revert doesn't delete anything. Instead, it creates a new commit that undoes the changes from previous commit. It's just like saying, hey Git, I messed up back there and let's fix it, by keeping the history. This way, your project history stays safe and keep moving forward. Now, there is a slight difference when it comes to Git Revert and Git Reset. Git Revert is used after you have made a commit to the local repository and want to undo it in a trackable way, while Git Reset is used before you commit or files within the staging area, where you want to completely remove commits from the history. Now let's understand Git Revert with a simple diagram. Just suppose A, B, C, D. Each letter is a commit. You say save change to your one of the projects. Now let's say commit C is having a mistake, but we don't want to mess up with the old history, the commit of A, commit of B, right? So we run a Git Revert on commit C, and Git adds a new commit. Let's call it a E. That cancels out what happened while doing the commit for the C. So here's the cool part. So commit E don't delete anything. It just reverses the C's changes and keeps your timeline moving forward. That's why Revert is safe to use in shared or public repositories. Let's go ahead and perform a quick lab for the Git Revert. So I will just check the Git version, whether Git is installed on this particular system or not. Okay, so I will create a directory called test revert. Now I will go inside the test revert. Let's see the contents. Anything is there in this file? No, nothing is there. So I will initialize the Git. So Git is initialized. Let's check the status. Okay, nothing is there. So I will create a file. Let's name it as test git revert. And okay, I forgot this operator. I will write some content into it. First code for cloud text club. Let's give it Control D. Save contents. Now I will move this particular file from my staging area and to the local repository. This is my first code. Okay, so let's write some more code within the same file. I'll just give it a test git revert, and this is my second code for cloud text club. I'll give it Control D to save it. Let me clear the screen first. Now let's move this again to the staging area and the local repository. Git add git commit -m. This is my second code. Okay, now I will write my wrong code for testing purpose within this particular git revert lab. Test git revert. I will say this as wrong code for cloud text club. Control D to come out of it. Let's move this into the staging area, then commit over to the local repository. Commit -m. I will mark it as a wrong code for the identification purpose. Now I have my wrong code and commit is in place. Let's check this with the help of a git status. Nothing is there, and the git log. So here is my wrong code and the commit ID. Now let's perform the git revert on the affected code and the commit, which is this one, right? So git revert and the commit ID of my wrong code. Now it is asking me put something there. Put it like is ignore previous code here. Now what it says after performing the git revert and the commit ID: master revert wrong code, please ignore previous code here, and we saved this particular file. Now let's see what changes occurred after performing the git revert. Cat test git revert file. Okay, now we can see the second code for the cloud text club. So it just moved one step back. Now I will go ahead and see the git log. So you can see here the commit ID, it has generated the new commit ID and it has reverted the wrong code. Please ignore the code here. This reverts the commit, this one. So this was the commit ID which it has reverted. Now let's proceed with understanding tags concept within Git. These are super helpful especially in the real world production environments. You can think of them like a sticky notes or like a labels. You can attach them to a specific commits. It is just like tagging the buckets, so you instantly know what is there inside. This makes it way easier for the teams to mark key pointers into the project's history, like a version releases or the stable builds. It is also helpful in when you need to track or deploy or roll back any particular changes within the production environment. So there are common tag commands in Git which can be used to perform a tag over a particular specific commit. So the command, you can use it as a like git tag with a -a and the tag name and -am and the message and the commit ID. You can also skip the commit ID if you want to tag the latest commit. In case you want to see all the tags, you can just write it a command like a git tag, and to view details about a specific tag, you can just write the git show and the tag name. To delete a particular tag, you can just give it git tag with a small -d and the tag name. So tags are a great way to keep your project organized, especially when you are managing multiple versions or planning the releases. Let's do a quick lab to see how to perform tagging within Git. So I will create a directory test tag. Let's move inside test tag. I will initialize the Git here. Let's create a file, test file 01. I will write the comments. This is my first code for CloudTix Club. Control D to come out of it. Now let's move the file to staging area and perform commit to the local repository. Git commit -m first code. Okay, so it has generated a commit ID after committing it into the local repository. Now let's put a tag to this particular commit ID. How to perform it? Git tag -a. I will put the tag of CloudTix using the message, first code, and the commit ID. You can also skip the commit ID if you want to take the latest commit. Otherwise, you can check the output of git log and provide the commit. Okay, I have pasted this 2 times. Okay, so we have put it the tag here. Let's check. So the tag CloudTix is now visible. Let's check the more detail about this particular tag. CloudTix, git show CloudTix. If you want to delete this tag, we can use the command git tag -d CloudTix. So deleted tag CloudTix. Now let's understand a very small topic of removing untracked files. Sometimes you will notice Git is showing untracked files when you run the command git status. This just means there are files in your workspace or a working directory that Git doesn't recognize. So let's say you create a new file, but you haven't run a Git add on it to move it into the staging area or local repository by commenting it. In that case, Git is not keeping an eye on it. It's just sitting there in your workspace or the working directory. In this situation, Git is just like, hey, I don't know what is this file all about. If you want to remove these untracked files, Git gives you a way to do that. You can use the command git clean -n. It's just like a dry run. This actually shows you the list of untracked files that would be removed. But doesn't actually delete anything yet. So this is just like Git is asking, are you sure you want to delete these files? You want to remove these files? In case you want to proceed further and forcefully delete these untracked files for real, you can use the command git clean -f. So let's go ahead and quickly see this particular concept within the lab to make things more clear. I will create the new directory, untracked files. Let's go inside the untracked files. I will create few files here: touch file 1, file 2, file 3. Let's check. So these files are created. I will initialize the Git here. Okay, now run the Git status. So you can see there are 3 untracked files, the file 1, file 2, file 3. Now let's run the command git clean -add. So you can see would remove file 1, would remove file 2, would remove file 3. So as we discussed, it's just like a dry run. This just shows you the list of untracked files that would be removed, but don't actually delete anything. Now to delete these files, we can use the command the git clean -f. Okay, now it says removing file 1, removing file 2, removing file 3. Let's check the Git status again. Okay, nothing is there. So it has removed the files successfully. So the next concept is all about the GitHub cloning. So the term cloning pretty much explains itself. You are making a copy of something. When you clone a GitHub repository, you are basically downloading the whole project from GitHub, a central repository, which we talked about earlier. Or you can say from the central repository to your own local machine or a computer. And it's not just the files, you also get the entire Git history. So you can see everything that has been done to the project so far. So when you clone a repository, you will get all the files and folders in the project, all the branches and the commit history, and also .git folder that lets you use the Git commands locally on the system. Now, what you can perform on these particular files is you can edit all of them on your local machine. You can create more branches to work on features or fixes. You can commit the changes to them. You can also push them back to the GitHub central repository from your local machine if you have the credentials for doing that. Now let's go ahead and see this quickly within our lab, how we can pull the repository from the GitHub by using the GitHub clone. So this is my GitHub central repository from where I'm going to clone this particular repository, the test 007, to my local machine. So I'm going to copy this link and going to run this command from my local machine, the git clone and the link. So it is cloning whatever is there in this repository from my central GitHub repository to the local machine. So let's see the file here. Okay, so we can see the test 007 here. I will clear this the screen. Now let's move inside the test 007 and see the files. So dictionary.yaml, multi-line.yaml, single line.yaml, all 3 files are present. These are the same files which are there within this particular repository on the central GitHub. Let me run this ls-la. So we can see the .git folder as well. That lets you use git commands locally. Let's see the git log. So we can see the commit history as well. So all the files and folders within this project are copied locally within the local machine, and we should be able to see the branches and whatever the commit history was performed within this particular repository, and also the .git folder, which lets you run the git commands locally. So that's it for now. In the next lecture, we will discuss and explore more concepts with other DevOps tools. So stay tuned for the latest videos. Please don't forget to like, comment, and subscribe to the channel.